Hello, welcome to the Helidon Screencast. Let's take a look at the MicroProfile messaging. MicroProfile messaging came as a need for formalizing the asynchronous communication between the microservices. As most messaging techniques we know, it's not only trying to connect the services between each other, but it can connect the beans inside same container. It's being done by the messaging methods, which are being connected by the so-called channels. The channel is actually a pair of messaging methods, and it can be also a pair of method of connector of any combination of that, or the two connectors. So let's look how it works. There is a message concept. The message is actually a wrapper for our item, which is being sent through the reactive stream. The message is a simple wrapper which has the callback for acknowledgement, which is nice because we can acknowledge that we received the message. So if we need to commit to some underlying connector that we have received the message, we can do it through the acknowledgement. The acknowledgement can be automatic or manual. This is the example of the manual acknowledgement. And here we can see the incoming method. The incoming method is a consumer. It consumes the messages from the upstream. Here we have a wrapper. The wrapper is optional. The underlying implementation could actually unwrap it for us. So if we had just the string argument here, we will get the same thing, but we couldn't do the acknowledgement manually. Here is an example of another incoming method with implementation of the message, so we can have our own metadata packed in the message. That's nice. Again, the acknowledgement. Here is the outgoing method, which is publishing. This method is being invoked every time there is a request from the downstream, and the result is will be sent to the downstream on the next signal. Here's the example of the processing method. Processing method, it has both annotations, so it's connected to the two channels at once. The one channel is incoming, which the messages are coming from the upstream through this channel, and the outgoing is sending the messaging to the downstream. It's actually equivalent. This one is actually equivalent of the map operator because it's being invoked for every item coming to the stream. There is much more signatures in a spec, but we can't cover everything in one screencast. There is nice concept of connectors. The connectors are really easy to implement, and they are provided with the MicroProfile config of the app with their own contacts, so we can implement it really easily because the connector is actually an application's code bean. We just need to implement one or two interfaces, and then we can create. Here it is. Here is the example. This is the connector. It's really easy to implement. We just implement those two interfaces, and then we can depends which one we want to use for producing or consuming some reactive streams. It's really easy. We get a config, we can play with that. Here is the example of the configuration. This is how we can configure which channel is connected to which connector. Yeah, and then there can be much more configuration for the connector here. And also there is a lot of there is the whole example of outgoing and incoming. This is the whole stream, which is this one is invoked only once. It's preparing the stream. It's preparing the publisher for the stream. This one is the map operator equivalent. It's processing the stream, and this one is consuming the stream. again invoked for every item coming from the upstream. And there's a lot of signatures with a lot of properties. You can see that. Let's take a look at some demo. I prepared a demo for you. You can find the demo on my GitHub. It's right here. Helidon messaging example, and you can play with it yourself. Let's check it out. It's standard Helidon MP project, so it's being started by the main method, which is really easy. And we have a simple application which got one resource. The resource has two methods. One method is a standard get method, which as a parameter is sending the message. The message is being processed by our messaging bean. We will get to that. And it has a second method which is registering the listeners to the server-sent events. So we can send the result from our stream to all the registered listeners. So we can actually see it doing something. So let's take a look at the message processing bean. Here is our example bean. It's really simple. It's got outgoing method, which is preparing the publisher, as you've seen before. It's got two processing methods and one consuming. And the interesting part is we have our own publisher here prepared. So we are creating our stream from this custom publisher. This publisher is created to emit the messages. It's a little more complicated, but so the demo is nice. So we have manual emitter. There will be emitter incorporated in a new version of the specification of reactive messaging. So this will be really simple with the next version of the specification. Our publisher is publishing when we call the emit methods, and it has enough requested items. So we are calling the emit method with this process method. If we take a look in the resource again, we can see that the process method is being called by the get method with a message we received from the front end, and that goes through the stream here. So we are preparing the stream. The stream will be using two processors. The first processor, this one, is actually preparing the processor. So this one is being invoked only once at assembly time. It prepares the processor itself. There is a processor with operator flatmap. Flatmap is serializing another stream into our stream. So we will, from our message, we will do we will multiply our message to 3 messages. Every message will be processed differently. So the first from 3 messages will be converted to uppercase. The second will be repeated twice in the same string, and the third will have reversed characters. And then we have another processor here, which is being invoked for every item coming through. So it's real map operator, and this will be just doing the wrapping to the outbound event of the server-sent events. And the consuming methods, this one is a broadcast, and it will be sending a server-sent event to our broadcaster, to all server-sent events listeners. So let's start it up. How does it look? Okay, we started already. Yes, we can start it. So let's have a look. Yeah, it looks nice, huh? There is a message. We will send something like "Hi, Screencast." Yeah, and we will click the send button. And have you seen it? We have 3 messages received by the listener. And the first message is being converted to uppercase, exactly as we did here. The second message is being repeated twice, exactly as here. And the third message has reversed letters, exactly as we wanted. So this is it. We can see how fast it flies. Yeah. We can even see that how the server send events works in his. It's it looks nice. So hi again, and everybody has 3 messages. Hi again. We saw this. Now we can try to change our operator if it does something, right? So we will change our operator to the simple flat map, to the simple map. Yeah, this is a map. We have a message, and we will just convert it to lowercase. So yeah, this will be nicer. It is now. Let's restart Helidon. Yeah, all my CPU is consumed by the recording software. That's just... yeah, we don't need to even reload this. So we should try something. Hi, Screencast in uppercase, and it's been converted to the lowercase. So you have seen how it works. You can play with it at home. Have a nice day. Bye.